Hey folks, we're back and we're going to be working on Phaser. We're going to continue. Now we've got everything kind of all set up and now it's time to start adding some of the mechanics and getting some of this stuff to work. So without further ado, let's open up our CodePen and let's get on Phaser.io. If you missed my first tutorial, you're going to want to make sure you go back and watch that where we go over this. Now, all this is coming straight out of Phaser.io, their Learn. It is the Making Your First Game. And it's a platformer game, and we're doing this in English, so here we go. So we're going to jump, and we were just about, we had just loaded up our platform. So we were just over here, World Building. All right, and this is the one that we had completed. We added our gravity and we added our platforms, and now we are ready to go to the next step. So we are on actually part 5 of the tutorial, Ready Player 1. And what we're going to do is we're going to add a player, and we're going to add some items here. I'm going to start with this and talk about it as we go. This is going to be in the create function because that's where we create our player. So we're going to go over to here, and we're looking for the create function. Here is our create function. Now, we set our platforms in here, and I believe it's probably going to be best for us to set our player over here. Because as you may recall, if you put the player behind, say, the sky, it'll seemingly be behind the sky. So I'm just going to paste what we had in here. We already had set most of this. So the first thing we're going to do is we're going to add basically, we're going to take our player, we're going to create a player object, we're going to add a sprite, but add it by giving it physics. Okay, so this is the position of where we're going to put it, and this is the sprite that we're going to do, and that was on preload. As you may recall, preload, we had created the dude, and so the dude was right here. And as you may recall, this particular thing is a sprite sheet, so it's a series of images. And the frame width and frame height would be the individual sprites that are in there. Okay, so that did it there, and creating our player just adds it here. And then we're going to add what's called a bounce, 0.2, which means when it collides, it's going to have a slight bounce. And then we're going to set a collision with what's called the world bounds. The world bounds is actually the boundaries of our screen, our game screen, or the world in which it lives, which is basically is going to make it so that our player cannot go outside of the room. Okay, so that is a collision. In fact, this is going to be our first phrase that pays. Now, what's that about? If you are new to my video tutorial, I have students that are following along, and I want to give them credit for having watched the video. And so to prove that they watched it, they're going to tell me certain phrases. Set collide world bounds makes it so a physics sprite cannot move outside of the boundaries of the screen / canvas. Okay, so that's what set collide world bounds does. So we're going to go ahead and test that out and see if we can get it to work. So that's our first phrase that pays. So if you're watching along, students, make sure you write that down, pause if you have to. All right, so let's see if we save it. Do we get our player? We hit save, we hit run. There he is. Now look at that. Did you see the little bounce down at the bottom? All right, I'm going to have to zoom out just a little bit, and let's run it one more time. Now you notice he didn't collide with the ground itself. He collided with the boundaries of the world. And you notice it's looking to the left. That's a good start. Okay, this is exactly what it should do because we've never told it to do anything otherwise. All right, let's go to the next part here. So now we're going to create some animations. This is referring to, I believe it's the game world. Yeah, I think it's all of the world because you see this player equals this dot physics dot add sprite, this dot anims. So I think this is our entire game world. And our game world has physics, but it also has animations, and that's just short for animations. We're going to create an animation. We're going to give it a key. So we have a key called left, a key called turn, a key called right. Now, if you've been following any of my other tutorials, maybe you're one of my students, we've been doing an animation state and doing a finite state machine or an animation state machine. That's what this really is. So we have going to the left, that's one state, turning is another state, and going to the right is another state. I believe. Now I could be wrong, and so let me just double check and make sure. Sure enough, I was correct. By the way, as you may recall, I forgot to mention this. This is our sprite sheet, and you'll notice there are 4 of them going to the left, and he's running to the left, 4 running to the right, and 1 where he's just facing there. And so it's exactly what I said. The key called left is an animation state. So let's take a look at it. We start at 0. 0 is always the first one. We end at 3. 0, 1, 2, 3. That actually is 4 because we started at 0. So we're going to animate. And this is what's real. Okay, this is just, to me, awesome. Because we can take one animation sprite sheet, and we can break up the sprite, one single sprite sheet, into a variety of animations. And I was also correct about the this keyword, that the this is actually referring to the whole game world. And you'll see right here, it says Phaser 3, the animation manager is a global system. The global system, in other words, is a system for the entire game itself. So I'm pretty sure that this is referring to the game. Now, I could be wrong, and please comment and tell me I'm wrong. I'm more than happy to be proven wrong. But now that we know what's going on here, let's go ahead and create these animations. So I'm going to copy all that, right click and copy. And now we're going to paste them into my platform. And I believe we still do it in the, yeah, sorry, I keep bringing that thing up. Okay. And I'm going to tab this stuff over, hit tab. And let's save our changes, and we'll run it. And we shouldn't see anything different at this point. But our animations are prepared and ready to go. Okay, so let's go back. I think we're ready now to move on to the next part. We already did the physics, collisions, animations. We're ready to move on. But I mentioned we're going to do a phrase that pays. So the key of the animation create is its animation state. And I'm just going to put this. Okay, so our another phrase, number 2. With this dot anims create, the key left, right, turn is the animation state. We just created an animation state machine. There we go. That is phrase that pays number 2. Number 3, this refers to the whole game world. He just gestured to all of me. I think of that. Anyway, all right, moving along. Okay, so we're ready. Let's get this thing going. Okay, we're talking about the physics, and remember we're doing arcade physics, so this is kind of cool. When this article was written, they had 3 different physics engines, shall we call them. There was arcade physics, impact physics, and matter.js physics. The arcade is a lightweight, fun physics, as some people like to call it. And so that the arcade physics is going to be easy for mobile browsers. And that's what we're doing right here. So when a physics sprite is created, it's given a body property. This is a reference to its arcade physics body. This represents the sprite as a physical body in a Phaser's arcade physics engine. So if we want to simulate the effects of gravity on a sprite, it's as simple as writing player.body.setGravity y300. Okay, and so I believe we set that gravity. Am I right? No, we haven't. We added the sprite. We haven't added the physics yet. Okay, But we're not testing for collisions between ground and the player. All right, so what we're going to do is we're going to add a collider. Okay, so we're going to basically, we're going to have a collision with platforms. Let's go ahead and set the gravity. And I'm just going to copy straight from there. And this tutorial is probably assuming that they already added this. I'm pretty sure we're going to want to do it somewhere in here. So I'm going to do it right to there, set gravity. Let's see how that behaves, see if that's any different. Does it fall faster? We don't know. Maybe. All right, and let's not forget a semicolon at the end of this line. Always remember your semicolons. That separates each instruction out. Okay, so let's move on to the next one, and now we're going to do the collider. Okay, so this collider is really cool because it does a lot of the work for us that we have to do in other game engines. Okay, it'll take these two objects, player and platforms, it'll test for collision, and it does a thing called separation against them. If you followed along my Game Maker GML tutorial, or you've watched the GML tutorial from Sean Spalding, he had done a lot of coding to help create that collision. This will do it for us. So that's kind of nice. Even though we're doing a lot of code here, let's just see if adding this to the game world, adding a collider between player and platforms makes it so that we land on the platform and not fall below it. Sure enough, we are now on the platform. Our game physics are starting to work. We've got time. Let's do more. All right, this is where we start having some fun. We get some control over our world. We get to control our player with the keyboard. And here we go. This is really cool. This is a built-in keyboard manager. We just set cursors equals this.input, keyboard, create cursor keys. And now we have access to all of our cursor keys. So cursor is going to represent basically the cursor, which would be the keyboard. Left would be the left arrow. Right is the right arrow. And then, so we can say if the left is down, we're going to set our velocity, and our player left will go to left. So the velocity of x, sorry, I'm not doing a good job explaining it. Velocity of x is, of course, distance and direction, right? It's magnitude and direction. The direction is being set by the x, which is horizontal, left and right. Negative 160 means towards the left at negative 160 velocity. What these numbers represent is kind of interesting to me. I'm not entirely sure how that works, but this is the number they're going to use. And then we're going to add the animation as well. And then we're going to do the same thing for the right. Now, I'm pretty sure this has to happen in update. Yep, it's in update. However, I'm pretty sure this is in create. So let's just see if I'm right. So we go over here, and in create, we're going to add. Now, you guys got to be careful when you're adding code in places inside of a function. You got to be looking at these, and I'm going to zoom in tight on here. Be careful about these curly brackets. Now, I'm pretty comfortable. I've done enough coding that I can find my way around. Usually, these semicolons are really helpful indicators. So usually the end of a semicolon is like the last thing of something. We can see that there's this 92 function update on line 92. So we can guess if we're going to be in our previous, if we're in the create function and I close it, you can see each function is sort of separate from the others. So sometimes it helps to actually collapse your functions. I mean, we're going to collapse this config. And here's like a whole overall structure of what's going on here. We have a configuration, we have a game object, and I'm pretty sure that this is always going to refer to the game. Then we have a preload, a create, and an update. Okay, so we're still in create. We're going to do the last thing in create, which we're going to add our add keyboard inputs. Why did that happen twice? Weird. Okay. I don't know how I did that, but that was pretty cool. Keyboard input. All right, now let's go to our function update. Now we haven't done any code. There's nothing to expand because I haven't done anything. So I put my cursor, so it's blinking right in there, and I hit enter. Now I'm going to do our if checks. Okay, so keyboard control of player. Okay, I like to add some comments. And that's that cursors. We're going to do an if. Right? If left is down, we're going to go left. And we're going to animate left. If right is down, and that's an else if. We can't do left and right at the same time. It's one of the two. And if we're not doing either, we're going to just stop our velocity of x. We're not going to go left or right. And we're just going to play the animation of turn, which in the last one you saw I really didn't do anything. Let's start with that. And then we'll do the next part later. I just want to make sure this is going to work. Don't forget to paste. I'm going to clean this up. I hate to do this because then it expands everything again, but there we go. So we're looking at update at this point. All right, so we're doing a lot of if, else statements. There are sort of three possible routes that this game can go. I personally like to put my else if and else on their own lines. I feel like it breaks it up just a little bit more visually speaking. Not sure we have to have an extra line return here, but there we go. Let's just go ahead and save it and run it. See if we can go left and right. We're going to have to zoom out. Look at that. Runs to the right. I'm holding down left, runs to the left, and he turns to the middle. Is that just beautiful or what? That is just awesome. Now I can't jump up. I can't go up at all. I can only go left and right, but that is pretty cool. So the algorithm for this is if the left is down, we're going to move to the left by setting a velocity x of a negative value. If the right is, and then if that's not the case, we're going to check to see is the right down. And if that is, we're going to go 160 to the right. And then if neither of those are, we just don't move left or right, and we play the animation of turn, which is really just basically this animation here, turn, which is just one frame. Frame number 4, a center frame, and a frame rate of 20 versus 10. And the frame rate is just how quickly it cycles through the frames. Okay, so it's kind of a quick, abrupt stop, I imagine. Okay, let me go ahead and do our phrase that pays. And here is the number 4 phrase that pays, and that's the algorithm for horizontal movement. If the left arrow is pressed, move left, set animation state to left. Else, if the right arrow is pressed, move right, set animation state to right. Otherwise, stop horizontal movement, set animation state to turn. That is the full algorithm. So that is a bit more for you to type out, but hey, it's a pretty awesome algorithm that can be used in other game engines as well, because that's player control, and that is essential, or at least one essential algorithm for any game designer to know. The final mechanic, and this is very important for a platformer, is the ability to jump. And how do we know we can jump? Well, there are two things we have to be checking for. Number one, we have to find out, are we pressing a jump key, which would be the up arrow. But not only that, because we don't want to be able to jump in the air, we want to make sure that the player body is actually touching down. And what this means, and I can break this down for you, is player, that's our player. Body, that's the physics body. Touching, it's already touching something, something is there, but in what direction? We could be touching up, left, right. In this case, it's down. In other words, we have to be grounded. We have to be on something. There has to be something underneath us that we have a collision with before we can go up, and at that point, we can jump. And so we'll add that, test our jumping, and see how that works. Now notice, oops, I'm going to go back a step. Now, remember I told you, you got to be careful about those curly brackets. The else here, this is the full one. By the way, this is part of the reason why tabbing is very important. Making sure you put right there. I'm going to put on here jump mechanic. Okay, This is its own if test, right? This is separate from left and right. Okay, so the jump mechanic is if the keyboard up is being pressed, in other words, the key is down, and we have something underneath us, and then we can jump. Let's test it, make sure it works. Oh yeah. I love it. You can run in the air. We do have a problem, Houston. And remember we said the collision bounds, we can't actually jump through that. I gotta say though, it's a pretty cool, we got little bouncing going, and the animation is a fun little animation. There's a lot we can do with this. This is already taking good shape here. I'm gonna give you the last phrase that pays because I am in such good mood. The jump mechanic, that's what the last phrase happens to be. So let's do that here. The jump mechanic is if, oh, up arrow is pressed and, very important, and the body is touching something underneath. Then we apply a vertical velocity. Okay? And a vertical velocity in this case is a negative value. This teaches us a lot. In game design, one of the first things you want to do is you want to figure out, in the case of the game world, you have to figure out where is the origin of the world. The origin of the world in Phaser, just like Game Maker Studio, is 0, 0 is the upper left corner. So the y of 0 is the top of the screen, and x of 0 is the left of the screen. So an upward velocity is a negative value. In other words, we're applying a value heading towards the top. Okay, so that's that velocity for a jump. Now we can increase this value and jump even higher. So let's try a 530 and save it and run it. Let's just see how high we can jump. Oh my goodness. That is a serious power up. Yeah, I like that. Ooh, we even hit the top of the screen. Did you see that? Okay, that was pretty cool. Now I can't jump up until I get to the bottom, but I can have some fun. It's like a little trampoline. Bing. All right, there we go. Okay, before I do anything else, I want to point out the vertical velocity in this case is 330 pixels per second, and I'm guessing squared, 330 pixels per second. So this is, a lot of times you set this value as a per game frame, but this is a per second. The other thing you need to know is there's already a gravity being applied. So the gravity being applied, we're working against the gravity. So at the beginning, we start with an initial inertia, which is pretty great, but then gravity keeps getting applied to it. So these numbers are a pixel per second, in this case squared. Wow, it's wacky. All right, so there you have it. Okay, I'm going to do part 8. This is going to make our game very interesting. All right, we're going to add a physics group. We're going to add a group of stars. Okay, so we're going to do, now this is a physics add group. And what we're going to do is we're going to make a variety of stars, and we're going to use a loop for this. So we're going to do 11 different stars. And we're going to do this set x, y. We have this x of 12, y of 0, step x of 70. And, okay, and then, okay, so let's just break this one down and I'll explain it. Okay, why have me explain it when it's right here? So basically, it's going to set the star. Apparently, when you create it, it will create one, and then it's going to repeat 11 more times. So we're going to have 12 stars in all. The set XY is used to set the position of the 12 children of the group. Each child will be placed starting at X12, Y0, and an X step of 70. So every 70 pixels, it will add another one. So the second one will be 70 pixels to the right. and then it just keeps on going. Um, interesting. At 82XO, okay, all right, 150 step values. Okay, not sure why we went from 70 to 82, but all right, let's go ahead and do that. We're going to get a little bounce value in them. And this is worth noting. Okay, remember this is a group, so we have multiple ones here. And there's this thing called iterate. And iterate means to loop or perform a function on each item in a group. Okay, so we have a group of stars. We're going to iterate over that group of stars. Now, stars.children means all of our stars that we created, the group of stars. So the children of the group are each individual star. And we're going to perform a function on each one, and that is set the bounce. And we're going to do this interesting. We're going to do a random bounce value between 0.4 and 0.8 on each one. So let's go ahead and add that to our game. And this is going to be in create, not in update. Okay, so let's sprinkle our world with stars. I'm going to paste all that in there. And I'm going to tab over all of this so it's all lined up. We're going to save it. We're going to run it. And we're going to get a bunch of stars. And they all fall through the ground, except for this one star that I forgot I created up here. This is a good time to remove that star. There it was. We don't need that anymore. Interesting that they got the little circles around. Wasn't the kind of star I was hoping to get, but we can always change that graphic a little bit later on. All right, so we're going to have to make sure we add a collision. Okay, not just that. So, and I'm going to get rid of some of these extra line returns. And how do we do collision for our other item? We did it with our player, and I think we did it up here. This .physics.add collider. I think we're going to need that for our stars as well. All right, let's see if we have that in here. Yep, sure enough. So we're going to add a collider, our stars with the platforms. So let's go ahead and do that. And then, oh, I know what the next thing is going to do. Okay. Add our collider. Let's save it and run it. And now watch, they'll stick. Oh, that's so fun. Oh, they come down and bounce, and now I'm going to want to collect all those, but I can't collect them. One, I'm going to need to have some kind of a collision, something to happen when I collide. And I also have to realize they're being layered differently. So let's see what they say. I'm going to add this thing called an overlap. And it's just going to see if one is overlapping the other. It's another type of collision. And we're going to, when we overlap, the player overlaps with any group in the stars, we're going to run this collectStar. What the null of this is, they're going to explain. I don't know because I am learning this the first time. But I'm going to copy this and add an overlap. All right, then we're going to create our own function. Now this function needs to happen outside of everything else, I'm pretty sure. So I'm going to go back here, and I'm going to run down to the very bottom, and let's just see if it works. Yes, it does. Boing. All right, we get the idea. Okay, so that was right. So when you create your own function, it needs to appear outside of everything else. Overlap. Let's see what the null of this represents, and we'll probably get some better stars. How about we just not worry about what null in this stands for, and we're just happy that everything works. So don't forget to add your collider, And then once you have a collider, and we do the overlap. I'm not sure why we have to do an overlap versus just standard collider. But let's see what the collectStar does. Okay, so let's just talk about this one more time. Player, when it overlaps with a star, they occupy the same space. We run a function called collectStar. And then on collectStar, we need to know what the player and the star is. Interesting. I didn't know we could call a function called collectStar and do this. So we pass it two items, the player and the star, which we set earlier, and we have this disable body. All right, so if you notice the star, what happens when you collect the star, the physics body is disabled. And there are two trues. I'm guessing it removes it from display and probably cannot react anymore. I'm not entirely sure. But there you have it. Okay, I think we're at a good stopping point right now. Here, look at all the things that we added. We added animation, we added keyboard control, we even sprinkled it with some stars that we can collect. We've got the makings of a fine game. One thing I'd like you to do when you have some time is play around with some of the velocity values of the movement, in particular the jumping. Mess around with these numbers to see what what is the perfect mix between all of these. All right. Well, thank you so much for watching. Stay tuned for more.